Hey students, this is your Professor Omelianchuk, and this is just the second lecture about strategizing derivations. And it's basically what we're just going to do today is just talk more about how the strategy works with especially more complex problems. And most of what is in this lecture is basically some more practice problems, all right? Because you need to be able to do this, all right? And so I can't stress this enough. When it comes to taking your final exam, you will have to figure out how to do this. Okay, so here's the thing. Again, here's the strategy, right? We talked about this in the last lecture. Is you got to identify the rule of inference that will be used to derive your target. Okay, that's the most important thing, is think about your target. Start with that. Don't look at your premises just yet, right? You look at those when you need to, right? But the first thing you have to do is figure out which rule of inference you're going to use to get that target. So always zero in on that. Then once you have an idea of what rule you might use, look at the requirements of that rule, and then let those become the new targets or sub-targets that you need to get in order to apply that very last rule that you're going to use to get your target. Okay? And then for any sub-target that's not a premise, return to step one, right? In order to determine which rule of inference that you'll use to derive your target, right, identify what type of well-formed formula that you're dealing with, right? So there's the different kinds, right? Atomic, conjunction, conditional, disjunction, negation, or biconditional. Okay, and then determine which rule are you going to use. Is it going to be an elimination rule or an introduction rule? Remember, elimination rules extract a subformula out of a formula, so try using those first, since they tend to be simpler. And if your target is atomic, use an elimination rule. Remember too that an intro rules always create connectives, so you should use them only if they generate the main connective of your target. And then just determine if the inputs of the rule that you want to use are available. Sometimes they're not, and so you'll have to try a different rule. Okay? So exercises on how we find the right rule, right, is basically here, I just kind of want to go over, right, something like this, right? This is out of the book. And let's imagine that you have a derivation that has these premises, right? So you're given those premises, and then the problem here says that for each formula below, suppose that the target of your derivation, right, is what's listed here, okay? So what's the rule that's going to be the best choice for deriving that formula, okay? Now, this one should be fairly easy and fairly straightforward, okay? You see BC, that's your target, and now you're given those premises. Is there a way that you can get BC out of the premises? Well, you could, it's right here, right? So if you have AF, and then you can get this piece, and you can get GJ, then you could get BC, but that seems like a lot of work. If you just look at line 2, right, BC is really accessible to you, right? You could use what sort of rule, right? Well, you could extract BC out of that using an elimination rule. And which elimination rule is it going to be? Well, you want to eliminate this part, this connective, and you want to eliminate all of that. And so that's going to be ampersand elimination. Okay, so you're going to use that on line 2 to get BC, and then you're done. Okay, you've got your target. Right? Okay, so what about BC ring AF? Okay, so think about this, right? We already know how to get BC by itself. We just got it, right, using conjunction elimination on line 2. But now suppose you need to get BC ring AF. Is there a rule that allows you to get that? And there is. Remember that you can introduce disjunctions. Okay, and disjunction introduction allows you to tack on whatever you need, right? So you can tack on the AF using conjunction introduction after you get BC by itself. And then you get BC, like I said, from 2 with conjunction elimination. Okay, then AF ring KA. Okay, so how do you get that? Well, you can actually just get that out of line 2, again, using conjunction elimination. Right, so there it is, right? There is AF ring KA. You actually don't need to use disjunction introduction here because it's just right here. You can just extract it out of this. Right? It's a sub-formula that's in part of a larger formula. What's the larger formula? It's a conjunction. So you just eliminate this piece and get that piece. Okay? Right, now, how would you get this? Okay, how would you get this? Well, we already know how you can get this piece. You can extract this part from line 2. Now you need to get GJ. Now, how in the world is that going to work? Okay. Well, on the last line, let's just think about what you're going to do on your last line. Okay. On the last line, what you're going to do, right? You're looking at this, okay, and you can't eliminate for this pattern up here anywhere. So you're going to have to create a conjunction, right? You're going to have to create a conjunction. And so what you're going to have to do is get this by itself on a line and this by itself on a line, right? So what you'll do then is use conjunction introduction after you get AF, ring KA, and GJ by themselves, right? So don't worry about how you're going to get GJ just yet, all right? This is what you got to do, okay, in order to get the target, which is this right here, on your last line. And that's how I want you to think, okay? Now, you might be wondering, well, how do I get GJ then? Right? How am I going to get GJ? Right? And this is actually pretty tricky. Right? This is actually not easy to see, okay? What we do here is we kind of look at, okay, we have GJ here in line 3. And so you might think I can get KA, right? But KA is part of a disjunction, all right? And so how are you going to get that out of there, right? So you think, okay, that's too hard, right? Maybe we can get GJ, right, from this biconditional here. If I have BC, and BC is really easy to get, so let's go for that, okay? In order then to get the biconditional, though, I got to get AF, okay? But AF is part of a disjunction. And you're just like, oh, how do I get it out of there? I can't just do disjunction elimination. I have to have like 3 different things, right? Now, whenever you kind of get backed into a disjunction like this, it's a pretty safe bet that disjunction elimination is going to be used on your last line. And in fact, it will be in this problem, all right? So here is what I want you to see. Okay, we're going to use disjunction elimination basically from lines 3, okay, because this here leads to GJ, right? So this disjunct right here, so here's our disjunction that we want to eliminate. We want to eliminate this disjunction, ultimately, right? And KA leads to GJ. And of course, AF, as you can see, also leads to GJ, right? And so what we're going to end up having to do then is get 3 things, all right? So we're going to get line 3, we're going to get this, and then we're going to get this. Now you would have to use arrow introduction along the way to do this one, and I'll just show you what it looks like. It looks like that. Okay, so here's what's happening in this derivation, all right? I figured out this is what I need to do on my last line. Okay, that's what that whole process back there was. Is I figured out I have to do this on my last line. So that requires me to get 3 things. Okay, I got to get a disjunction on a line to eliminate. So that's what I do on line 2. Right, I extract this disjunction out of line 2 and I write it down on line 4 using conjunction elimination. All right. Now I already have one of the other pieces that I need. I need like this conditional here. It has KA that leads to GJ. And so that's one of the disjuncts here has a conditional already going to GJ. So now what I need to do, right, is I need to get another conditional where AF goes to GJ. So that becomes a subtarget. And that's what's written down here on line 9. That's what I'm going to need, right? That's what I cite right here. But I have to create this conditional. And when I have to create the conditional, I have to create the main connective, which is an arrow. And whenever I have to create an arrow, I have to use arrow introduction. Arrow introduction tells me to assume the antecedent, right? So I suppose that AF is true and I start a subderivation. And now I have to derive GJ, right? I have to derive DJ. Okay, I have to deduce GJ from AF, right? So that's what I end up having to do now in this subderivation. So I assume AF, okay? My assumption along with line 1 leads me to get BC double arrow GJ from lines 1 and 5, right? It's easy now to get GJ out of this biconditional. I just need to get BC, and I know how to get that. We talked about that. We use line 2, all right, and we use conjunction elimination. I get BC. And then I'm able to use lines 6 and 7 together, and I do biconditional elimination and get get GJ out of that. Okay. Now I've deduced GJ from AF, and so I can actually stop this subderivation. I can discharge it, and I move back to the left, and I cite lines 5 through 8. 5 through 8, arrow introduction, and then now I have all three of the things I need. I have my two conditionals, right, where the antecedent of each conditional is in a disjunction that I want to eliminate. What can I eliminate for? Well, the target that I want, GJ. Right, so I know that's kind of complicated, all right? I know that it's a lot, right? But that is basically what I figured out, okay? The same is going to be at work in this particular problem, right? Now, this is a really hard problem, and I'll show you why. You have to do disjunction elimination again on the last line, okay? The reason why is because, right, this is what I need to get, right? Now, notice that AF is leading to the target that I want, okay? AF is in a disjunction, right? And so what I'm going to have to do, right, is create a conditional where KA leads to the same thing, BC double arrow GJ, right? So I'm going to have to use arrow introduction again in this one along the way. Here's how it looks. This is a complicated one. The reason this is complicated is follows, all right? I know that I want to use disjunction elimination on the last line. I figured that out, right? Just kind of the process of elimination. Just going back to this here, right? I mean, I've been down this road before with this thing, right? In order to get AF out of here, right, I would have to eliminate this disjunction, okay? But I can't. Right, but I can get this. So I already have two parts. I can get this really easy by itself, and then I can get this on a line by itself. Now I just need to get this thing, right, on a line by itself. All right, and so that's what I'm up to. Okay, so I get my disjunction on line 4. I already have this one piece. Okay, so now what I need to do, right, is make this thing. Right, I got to make that thing. Okay, because that's what disjunction elimination requires me to do. How do I know what to do? Well, that's just what it requires. Okay, so what I got to do then is make this conditional. Right, I got to make that conditional. So when I'm making a conditional, I have to use arrow introduction, and I assume my antecedent straight away on line 5. So I assume that. Right? But now, okay, what I have to do, what I have to derive from KA is actually I have to derive this biconditional. Okay, but biconditional introduction, if you remember, requires me to get two conditionals, right, to introduce, right? And so what I'm going to need are two conditionals look like this. I'm going to need a conditional that looks like this, BC arrow GJ, and GJ arrow BC. All right, so I got to make those two conditionals. So now I have to create two conditionals from scratch because I don't have them anywhere up here. Okay, so what I'm going to do is I'm going to start another subderivation, and that's what I do right here. And I assume BC because this is one of my subtargets now, and I'm going to derive GJ from BC. Stay within the scope of the subderivation. Now I can do that because, right, I have BC right here. Okay, I assumed it for the sake of arrow introduction. How do I get GJ? Well, look at line 3, right, and 5. Notice that I can get GJ, right, from lines 3 and lines 5. Okay, so I get that, and now I have BC arrow GJ, and I have oh, I got a virus detection software. No threat. Okay, thanks. All right, and so now, sorry for the distraction there. From lines 6 through 7, I get my conditional, and then I have to create another conditional. I got to create this one. So I assume my antecedent in line 9. I eliminate for BC from line 2, and then I get 9 through 10, right? I stop that subderivation, move back to the left, create my two conditionals. Now I have my two conditionals, and from 8 and 11, I can introduce the biconditional. Now I've deduced the biconditional from KA, And so I could stop that subderivation and write lines 5 through 12. 5 through 12. And now I have this conditional right here. And so now I have all three things I needed. I needed this, I needed this, and I needed this in order to do the problem. And now I can do disjunction elimination citing lines 1, 4, and 13. Right? That is not an easy problem. Okay, that is really hard. I understand. Maybe you're kind of lost through this. If you feel that way, that's perfectly normal. Okay, but you will get this eventually. Again, you have to really know how the rules work and obey them. Right? But the basic idea here is that what I've done in every case is just work backwards. I work backwards from the target, right? I figure out what rule I needed to apply. What did the rule require? Well, it required this, right? And this, and this. And so then I worked to get those things, right? And I had to do a lot of work here to create this one, right? But I worked backwards in each case. Right? That is what I did in each case. And so that's what the whole point of this big exercise was to do. Right? So here are some practice problems that you can work through. Right? They increase with the level of difficulty. I should say you don't have to make any assumptions at all to do these practice problems. All right? So don't worry about doing arrow introduction. Right? But you will have to do some disjunction elimination, right, with some of these problems. And so work on those, right? There is an answer key that you can look at. And the last thing I wanted to talk about was just the homework that is due for today. Here it is, homework 8. Now, what you're going to be doing is just using direct rules of inference here. You won't have to make any assumptions, okay? You won't have to make any assumptions with any of these, right? So to get to just, what you got to do is to just focus in on the target here, right? Not LE, and try to get it, right? So what you're going to have to do then is get this piece, right? And you can get that from JA using disjunction introduction, all right? And you just kind of work your way through these 5 problems, do your best, right? If you have questions, just let me know, right? Here you have to create a biconditional. Okay, so you have to figure out how to do that. That's going to be used on your last line, right? And so work on those. Turn those in. Try to work on them with each other if you can, and ask me any questions if you have problems. And I will talk to you later.